Hey everybody, welcome back. I'm Deez, this is my workshop, and today we're gonna get on with probably some small projects today. I've got a couple other ideas in the hopper that I want to work on, but this is kind of one of those videos after I got done messing with this lathe. We got the headstock, I did some initial test cuts. I'm gonna do a little bit more testing before we get on to that next project, which I've got a lot of great ideas from everybody, but that next project I'm really thinking about making one of those finger engines and get into maybe model engine making. It really will help me hone my skills and use both machines in order to produce those small engines. Really interested in that. The whole world of model engines and locomotives and things like that is very fascinating. It just goes on and on. You can spend an incredible amount of time and effort with all that stuff. Locomotives are probably going to be a little too far out of my skill set right now, but some of these small model engines are very intriguing. I think I can knock some of these things out, and I'm really curious to do it. So you're probably going to see me focusing on some of that stuff as well as all the other projects that I like to work on. But today we're just going to do some turning. This is some 12L14 that I purchased. I just want to do some test cuts and see how this is running. I think we've got all of our pulley issues knocked out. Things are looking good. We got both machines in operation. We got our X-axis feed for the mill, the lathes back. We're ready to go and start making those projects. So I'm going to show you, just get you in here and show you some test cuts of this. We've got a Facemill to test on the mill. That's a new piece of tooling that we have, and just all kinds of different tests that we're going to work on today. And I'm going to bring you along for the ride. So thanks for watching. I hope you enjoy. Let's get started. Hey everybody, welcome back. I'm Deez and this is my workshop. Today we're going to look at this right here and a little closer. I showed it in a previous episode. This was purchased and I guess it was found pretty dirt cheap online and sent to me as a gift, I guess you could say. And what it is a Facemill. I'm pretty excited to have this, to be honest. Problem is there's no arbor. The challenge is, and someday I want to make an arbor for this with a straight shank. I think that would be pretty fun. You know, you just mill your shaft, make it 1/2 inch, 3/4 inch, full 1 inch, depending on what kind of collets you have. And then you can make some steel or aluminum or some dogs that will screw into the side of that shaft and they will lock into place. And then you will have to tap and thread the end so that it all fastens down tightly. So someday I'm going to make one of those. However, this is too enticing not to use right away. It also, by the way, it came with inserts for it, so we can get those on there. But again, this is too enticing not to use. I'm ready to use this Facemill. Right now I have a fly cutter. That's the biggest area that I can cut, but you got to go really slow and chips go everywhere. Really anxious and curious to see how well this thing does. But in order to use it, I need to have a arbor. So I looked online. I was like, I don't know how much this stuff costs. Well, I looked online and I found something. That's what this should be. Let's find out together. Okay, there's that. In my bag. And I went ahead and got an R8 Arbor to hopefully fit in this thing. I don't know. I looked, I think I got the right thing. It's, for those curious, R8-FMB22, 7/16, 20 is the thread on the end for my drawbar. I'm pretty sure. But that's what you're looking for, R8-FMB22, if you get one of these. Facemills, this particular Facemill, by the way, is a 400R 5022. So I'm pretty sure this is going to work, but we won't know until we actually put it on there. So let's get it out of here. Take a look. Okay, there it is. It's oiled nicely. It's made about like every other R8 that I've got. The dogs on the side are already there. And again, this defeats the purpose of making my own Arbor, although I'm going to do that someday just as a challenge. But to use this thing, by the way, it was 20 bucks. You can go to Amazon and find your own. I'm not going to post any links. But let's see here. This should, you can see, this should mount in here. Should. It's pretty tight. Oh, there we go. There we go. And then this will go down here. Screws on. There we go. So that's it. That R8 will fit right up inside the taper of my milling machine, and I'll be able to use this thing right away. Again, I do plan on making my own Arbor and being able to mount it in with ER40 collets that I have. But for now, I wanted to start using this, and I've got a bunch of other projects I'm getting ready to work on, so I just wanted to get this thing going. Plus, I think this is, I know putting things in and out of that Arbor or the drawbar is kind of a pain, but it really is for me, it seems to be the best way to get things installed and connected up there, and they mount as flush as you can get up to the headstock in order to have enough travel for everything else. Wanted to share that with you. Pretty cool, pretty excited to have this, and I'll get some inserts installed on this, and we'll do some test cuts at some point. All right, that should slide out. It does. So there, we need 4 of those. And we're gonna put those on here. Start with this one. It's decent made. These aren't real super chintzy screws. I mean, they seem to be pretty decent. Let's get these inserts on here. We'll start here. And again, I'll start with this, but we'll snug it down with the other. There's one. We'll just work our way around, and then we'll come back and snug them up. Good, 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 man. Good. Today we are going to do some more test cuts. Part of this video I'm doing test cuts on the lathe. Since I got my lathe back put back together, I've been cutting some 12L14, cutting some mild steel, sharpening some brazed carbide, some high-speed steel, and just kind of getting things back in order. I may not show it, but I'm going to tighten down the carriage. It's been a while since I've revisited that on the lathe, so I'm going to be tightening that thing up, make sure there's no loose nuts and connections so the carriage is solid. And what we're going to work on next is going to be some testing this Facemill. So this Facemill showed up one day. I was a little surprised, and it was just a purchase for several reasons, but it was sent to me. It was cheap as chips, and it was suggested I make my own Arbor for that, and I will someday. But considering how cheap this thing was, and it is an R8, I went ahead and bought an Arbor for this, because once you start making collets and arbors and things, you really start losing a lot of height. So this will mount it as flush as I can get it. But we're gonna mount this thing up, and we're going to cut some mild steel. This is hot rolled mild steel, rectangular. And then we're also going to take this little chunk of aluminum that I have, And you can see the milling marks from just an end mill, either 3/8 or 1/2 inch. That probably is 12 millimeter. End mill, doesn't matter. But when you run an end mill across, of course, you get those striations and those marks, that pattern. It's still flat, as flat can be, but you're also getting some marks. And sometimes you want a really nice surface finish, and I'm really curious how this Facemill does. Usually I'll use a fly cutter, but that takes you have to go real slow. There's only 1 point of cut for every revolution. This has 4, this particular fly cutter, and I'm really curious what this can do. Might be able to really, chew down some material. If I'm working on different projects, I can really get something with a decent finish and down to the finish depth or measurements that I'm looking for. So we're going to head over to the mill. We're going to put this thing in, and we're going to test both the mild steel and this aluminum. perhaps that was a bit much of an aggressive cut. However, the lathe, or the mill, handled it very well. You can see all the chips. It was we'll do a measurement. I'm kind of curious. I didn't mean to take that deep of a cut, but wow, it threw some chips. It did pretty good. You can see the chips down there. Kind of a mess, but I do agree that it's less messy than the fly cutter. But here's the depth of cut that we took. A little more than I thought for a test cut, but it worked. Well, we just got done testing the Facemill. It did a pretty good job. Is this the first side? I think this is the first side that we tested. You can see the little grooves in there because I had a little higher of a feed rate. I didn't go down too far. You can still see a little bit of some mill marks from the end mill that I used in the past. Then we flipped it over and we did this side at a slower rate, and it looks a little better. And then we did these two sides. There's one. Just testing. Piece of aluminum, and then here was the other side. Looks pretty good, I think. Didn't deburr it or anything. I need to. So that was aluminum. It did a very good job. I needed to use some oil. I had a tiny bit of galling on one of the carbide tips, but I just wanted to just get through this small piece. And then I did a piece of steel. Now this, I went a little bit deeper than I thought I would for a test, just a test piece. There's a piece of steel. Let's deburr this one a little bit if we can. This is A36 mild steel. That's better. Just for handling here. Okay, so we got that cleaned up a little bit, but you can see, so it doesn't look as good. It is A36 steel. It was a deeper cut than I had wanted to perform. It's just a test cut. It's very smooth. I came in and then I went back, and then I came and did a climb cut back out just to square off this edge and just do some testing. But I'm sure I could get a better finish than that if I played around with it. But look at that depth of cut. I was not anticipating that for a test. And I know this is a rough cut surface, but let's check this anyway, since we can. What do we got? So I've got my dad's trusty Lufkin depth micrometer. Let's use this thing. It's not going to be absolute precision. It just gives us an idea of what the depth of cut of a test that I did. Right there. I don't know if that'll lock or not. So we are at 50 plus almost 11. I'm going to call it 55 thou, or 50 thou and 5/10, 4/10. So about a 50 thou cut. That's pretty good, I think, for that depth of cut on the mill. Just curious. Yeah, 50 thou, 53 thou according to this. Again, this is rudimentary, I'm just getting a rough idea. So I took a 50 thou depth of cut for my first test cut on A36 mild steel. It chewed through the chips though, so I'm not unhappy with that. The finish isn't fantastic, but if I went slower or went down another 5 thou and just cleaned that up, it'd probably look a lot better. I just wanted to do some test cuts with that Facemill. I used the aluminum and I used the steel, and it turned out pretty good. I like that tool. You can take off a lot wider cuts rather than going back and forth with an end mill. It's a great tool to have. I'm really happy to have it. So I hope you enjoyed. We did a little bit of everything today, and thanks for watching, and I hope to see you on the next one.